Have you seen this one? It's one of the most controversial equations in whole mathematics. You see here, we add continuously nines after nines after nines after this decimal point. But how does this even add up to 1? This doesn't make any sense. Okay, let's make it make sense to us. It's a pretty beautiful result, but before diving into mathematical formulations, we'll have our intuition. To understand why 1 half plus 1 fourth plus 1 eighth plus equal to 1, then you'll have a better idea of why that quality is true. Here what's happening is that we have 0.9999. People often like to write it in this, like it or this. Both of three of them are the same. Now we're gonna work with this. Let's define this thing as S. S is just a variable, and notice here that the 0.999 can be written as 0.9 plus 0.09 plus 0.0009 and so on. X. Now we can write it and 9 by 100, 9 by 1000 plus so on. You see, at some point it's gonna be 9 divided by infinity. Not infinity, but a very close value. And what this thing is gonna be doing is making it 0. So at some point this value will converge in this. The last term would be 0. As we know, if the last term is 0, that series converges. So it's a convergence series. But how do we prove that this equals to 1? Now here comes our infinite series formulation, or I'll use just basic algebra. S equals to 9 by 10 plus, take here 1 by 10 as a common factor. This is going to be 9 by 10 plus 9 by 100 plus 9 by 1000 and so on. Notice here that this thing is the same as S. It's right over there. It's going to give us S equals to 9 by 10 plus 1 by 10 times S. Now what's going to happen is that 9 by 10 plus S by 10, if you write it this way, 9 plus S equals to S. Multiply both sides by 10. S 10 times S equals to 9 plus S. And take that S to this side, or subtract both S from both sides. We're just gonna get 9S equals to 9. And if you divide both sides by 9, we just get S equals to 1. And that's why we can say that 0.9 continued is equal to 1. Hope the debate is over in this particular problem.